In this section, we're going to look at a brief introduction to trigonometry. Introduction to trigonometry. Trigonometry is based on three functions that we call sine, cosine, and tangent, and they're defined based on a right-angled triangle. So let's look at the right-angled triangle. Let's say this is the angle we're looking at. That's represented by theta. This side, which is part of the angle, is called the adjacent side. And this side opposite to the angle is called the opposite side. And the longest side, the side opposite to the right angle, is called the hypotenuse. But we'll just use symbols. Let's call this A, this one B, and this one C. Now let's define the trigonometric function. The trigonometric function cosine is defined to be the ratio between the adjacent side and hypotenuse. It's written as cosine of theta, and that equals adjacent side divided by hypotenuse. And then we have the sine function, is abbreviated as sine of theta, and is defined to be opposite side divided by hypotenuse, b over c. And the third function is tangent. Tangent is abbreviated as tan theta, is defined to be opposite side, b, divided by adjacent side. So these are the three definitions of the trigonometric functions. Now, the only reason these functions are important is because they're available in the calculator. So using your calculator, you can solve for some missing values. Let's look at some examples. For example, let's say we know this angle is 60 degrees. Maybe we know this one is 20. We're going to try and find out this side over here. Okay? Now the trigonometric function relating adjacent side to hypotenuse cosine. So we can say cosine of 60 equals x adjacent side divided by hypotenuse. And then from your calculator, you'll find out that cosine of 60 is 0.5. Okay, this one is 0.5. So we have x over 20 equals 0.5, and then that gives us x equals 10. So it helps you to calculate missing values in a right angle triangle. And another basic relationship with sides is, of course, the Pythagorean theorem. Pythagorean theorem states that c squared equals a squared plus b squared. So from this equation, if you know two sides, you can figure out the third side using this equation, which is Pythagorean theorem. How about if the angle is missing? Let's say you know these numbers 310, but this number is missing. How do you go about it? We have to define the inverse trigonometric functions to solve problems like this. So let's look at the inverse trigonometric functions. Inverse trigonometric functions. They're defined as follows. If cosine of theta equals a, then cosine inverse of a equals theta. Okay. If sine of theta equals a, then sine inverse of a equals theta. And if tan theta equals A, then tan inverse of A equals theta. That's how the trigonometric functions are defined. So basically, the cosine, sine, and tangent trigonometric functions, given the angle, they give you the cosine, but the inverse functions, there is the opposite. If you give them the value of the cosine, they give you the angle. Okay? So let's look how these functions help us. For example, let's say we have the following. Let's say this is 5, this is 10, but we don't know this angle. Okay, let's call x. Okay? From the definition of cosine, we would have cosine of x equals 5 over 10, or 0.5. And now, using the definition of cosine inverse, we can say that x equals cosine inverse of 0.5. These inverse functions are also available in calculator. From the calculator, we'll get that this equals 60 degrees. Now let's look at coordinate systems. Coordinate systems are systems that associate numbers with points. This is a system for associating numbers with points. Numbers with points. First, let's look at the one-dimensional coordinate system, or the number line. Number line. So a number line associates numbers with points on a line. Okay. Now we're getting the reference point, and the reference point is called the origin. So in this case, a point is associated with its distance from the reference point. Okay, so this distance is the number associated with this point, but there are 2 points at the same distance from the origin, so we identify numbers to the right as positive and numbers to the left as negative. So in a number line, points are associated with their distances from the origin. The number associated with the point is the distance between the origin and the point. And we identify points to the right as positive and points to the left as negative. And then we have the two-dimensional coordinate system. Two-dimensional coordinate system. This coordinate system associates a pair of numbers with points in a plane. This one associates a pair of numbers with points in a plane. In this case, we need 2 reference lines. Okay, we have a vertical line called the y-axis, and then we have a horizontal line called the x-axis. So this is the x-axis, sometimes called abscissa. This is the y-axis, sometimes called the ordinate. Okay, so the goal is to associate a pair of numbers with points in a plane. For example, let's take this point. There are 2 ways of doing it. They're called the Cartesian coordinate system and the polar coordinate system. In a Cartesian coordinate system, the 2 numbers are taken to be the perpendicular distance between the point, the y-axis, and the perpendicular distance between the point and the x-axis. So one of the numbers associated with this point, and with this distance over here, we call the x-coordinate, and then we take the perpendicular distance between the point and the x-axis, and we call the y-coordinate. And this point is identified by the ordered pair xy. Okay, so these two numbers identify this point uniquely. Okay, there is only one point which is this much to the right and this much up from the x-axis. And then there is another coordinate system called the polar coordinate system. In the polar coordinate system, a point is identified by its distance from the origin, represented by r, and its angle, the angle formed between this line and the positive x-axis, theta. Okay. Of course, these two coordinate systems are related. Okay, as you can see from here. Let's put them in triangle. So that's what we have. This is x, this is y, this is r, this is theta. Okay. Now, from the definition of cosine, we have cosine of theta equals x over r, or we get x equals r sine theta. Okay. And then sine theta equals y over r. That gives us y equals r. This is cosine r sine theta. Okay. So these are the formulas that take you from polar coordinates to Cartesian coordinates. Okay. And to go the other way, from Cartesian to polar, we can use Pythagorean theorem. Pythagorean theorem says that x squared plus y squared equals r squared. So that gives you r equals the square root of x squared plus y squared. And then we can use the definition of tangent. Tan theta equals y over x, or theta equals tan inverse of y over x. So these are the formulas that take you from Cartesian coordinates to polar coordinates. We're going to use these formulas very often in physics.